everyone. Thank you for joining the session today. I'd like to thank the team here at Geoawesomeness, Alex and Mutu, for providing the opportunity here to speak with the 100 or so people that are on the session today. Today, I'm going to talk about bringing spatial data together to provide insight and clarity to support digital transformation related to the construction industry. So that just a little introduction. My name is Dave Braig, and I am the Smart Construction Project Manager here at Cesium. As many of you may be aware, Cesium is a visualization platform for 3D geospatial data. The Cesium platform spans open source components, support for providing open standards and data sharing, and Cesium Ion, which is our SaaS on-prem tiling and visualization solution. Cesium itself started back in 2011 at Analytical Graphics, and this past June, we celebrated our 2-year anniversary of Cesium as its own company. For myself, I joined Cesium about 1.5 years ago to help support the smart construction development and production planning. I've been working in the geospatial industry for over 20 years and have witnessed the explosion of data, technology, geospatial awareness, and adoption of geospatial technology and data formats. Over my career, I've spent time collecting and processing data, photogrammetry, sitting in the machines and doing feature collection direct from imagery. I've supported development and implementation of geospatial solutions for a wide range of customers from state and local governments to federal and private industry. And then with the background in GIS and coming out of that space, we're all about data layers and transforming the real world into digital versions, creating those stacks of layers, and then building that data so that we can use it to inform decision making. I can ask questions of that data to provide answers that are specific to me or to my customers or to my industry. Today, we're going to talk a little bit about digital transformation inside the geospatial context and specifically around construction industry. To me, bringing together people and the data to provide answers is really the heart of digital transformation. In the geospatial industry or any industry that have map products, many of us experience what happens when you gather people around a map, whether it's a printed map, a digital 2D map, or even a 3D map. Invariably, people start to ask questions about that map. Where is this location compared to something that I know about? How far is this from where I live or where I work? What did this look like before I even moved here? What else is around this particular area? It's no longer just about viewing the data, but being able to perform analysis with the data across the data sets to derive answers, if they're as basic as the ones I just mentioned, or the more complicated ones. The number and types of data available to support this types of analysis are increasing year over year. Some of this data is massive, has high frequency of updating, but the tech is finally catching up to the demand of this data. 3D geospatial data is widely available, now creating a huge opportunity to incorporate the data into a common platform or an application. The challenge is really being able to support these larger data sets efficiently while also being able to adapt to new updates and new data sources. And this is really where Cesium comes into play. You can think of us like a game engine for the real world with data fusion for different data types, the next gen Google Earth, or a digital light table where we can gather around to ask questions in a geospatial context. We provide a SaaS and on-premise subscriptions for 3D geospatial content, some of it that we curate, such as the global terrain data set, as well as pipeline tools to optimize users' data of your own for 3D streaming, just like YouTube optimizes raw video for streaming. We pair all of this inside of an open source graphics engine, custom written for the performance and precision requirements of 3D geospatial applications. It all runs in a web browser on any device and is really built for time dynamic applications. And then we look for industry partners like Komatsu to partner with and help build solutions alongside with to help transform and inform industries. But what data are we actually talking about here when we start to talk about all these different data sources? The one that we're probably most familiar with here is terrain and imagery, whether this is captured from satellite, aircraft, or more and more via UAS or drones. The photogrammetric sources provide the images and are processed into terrain surfaces such as DTM or DSM surfaces. And these photogrammetric sources can go beyond just the pictures in the terrain. We can provide detailed 3D scenes that offer the foundation for a digital twin. In this case here, this is a 3D photogrammetric model of 2-centimeter resolution of Philadelphia. 3D models themselves present another data source that can be integrated with inside the visualization platform, including open source street map buildings that are available through Cesium's platform. These models can provide more details with attribution and styling captured at the building level. And as with any data, it can be as simple such as basic outlines with simple information, or complex photorealistic representations, depending on the type of questions we expect to ask of the data. At a larger scale, we have point cloud data. Point cloud data typically derived from terrestrial, airborne, or vehicle-based sensors, or as a byproduct of some of the photogrammetric processing. Many of the commercial applications that are available now allow you to take drone information, create the ortho images, create the DTM surfaces, and also create point clouds from those photogrammetric, from those images. Point clouds and LiDAR data have been available for a long time, but they've always been too large, too massive, too unwieldy to actually do anything with. But the tech is catching up, and we're now able to manage these large data sets efficiently enough to incorporate them into analysis with inside of a web application. So some of the point clouds, for example, in here, we're looking at the one in the lower right is a 1 millimeter resolution. So it's almost photorealistic, but if you were to zoom in on that, it would be made up of individual points, each with their own measurements, X, Y, and Z values within inside of those points. Taking it a step even further, we can go inside of buildings with BIM and CAD models. So now we can really present a true digital twin of buildings, both externally and then internal infrastructure of the buildings as well. More specifically, we can take all of these concepts and apply them to industry solutions, like we're doing here with Earthworks, and we're going to talk about today with our Komatsu partners. As we'll be seeing with the other presenters, there's several different data sources available that can be integrated with a common dashboard, including pre-construction design files. So these could be XML, DXF design files coming from CAD data, survey and ortho photos from drone collections, as-built information from intelligent control construction vehicles. And each of these data sources have different formats, file sizes, and update frequencies. The design files might only be updated a couple times over the course of a project. The UAS data may be weekly or monthly, and as-built information could be daily or even hourly. All this information needs to be processed, displayed, and made available to make timely decisions on progress and planning activities. Moving us really towards being able to ask the questions of the data I have available, and ultimately the heart of digital transformation. But to get there, we still have some hurdles to overcome. Having all this accessibility to data, imagery, GPS, LiDAR, it's amazing. But the real power with all these data sources is making it valuable to the users. From the most mundane task to complicated workflows. If you cannot help or at least meet the current workflows, it doesn't matter how fancy the data or the solution is. In the construction space, this paradigm is front and center, something my co-presenters today will speak to as well. Typically, the industry has late adopters of new technology. They are comfortable, confident, using the workflows and tools they've developed over decades of experience. Paper maps over digital products, tried and trusted solutions over innovation and cutting edge technology. And we also have to be aware of the natural resistance to change. It's hard to change in any industry. Ultimately, we need to build trust in the data and the applications that use that data. We must show the value of the data and how it can help on day-to-day tasks. So how do we do this? To help build that trust, we really need to allow users to perform similar analysis, tracking, and reporting that they're used to in their day-to-day work, but also make sure that we're ensuring that we have accurate locations, measurements, and the data. All of that stuff is accurate, and it's critical that it's accurate, that they can build trust with inside the data formats. The ability to speed up repeatable tasks or to reduce schedule and job site man hours. What's the value? Why do I want to make that transformation? And what's going to be the advantage to me if I do this? Leverage other investments. So if there's an investment in drone capabilities or intelligent machines on this job site, can we leverage those investments and bring that data to the center and make it more accessible to a wider range of users? My co-presenters from Komatsu and Hunsinger today will provide more details on these areas and how we are advancing digital transformation in the construction industry. Cesium's always looking for ways to push further and further and innovate with new technologies. So as we kind of look at where we are right now with smart construction coming up, we also want to keep an eye on where we want to go next. We continue to look for ways to make the vast amounts of 3D data accessible to support decision makers in different formats. AR solutions, augmented reality solutions, can allow users to view cut and fill measurements or view design data directly on the site. Or they can measure stockpile locations via the LiDAR sensors that we're now seeing available in iPads and iPhones. AI, or artificial intelligence and machine learning, can help identification and automated classification of features such as buildings or construction vehicles with inside of imagery and 3D terrain, or support automated targeted flight planning to capture areas and work across the site. A little closer to home, our background in gaming technology at Cesium naturally leads us towards bringing this data into virtual reality solutions and ultimately the metaverse. VR solutions can allow project managers to view current site conditions from the office or another part of the globe. Being able to have an immersive VR experience for a construction site can reduce safety concerns on site visits. No longer do I have to travel to the site. I can sit in the job site office in the headquarters and view the current status of the site inside of a VR environment. I can reduce the time inspecting large construction sites. So through VR, we can navigate an entire construction site in seconds rather than physically driving to a site and then navigating across the entire site with the ability to show the current 3D terrain of that site to provide up-to-date information and progress tracking. You can effectively communicate issues, challenges, and site progress to project stakeholders, whether that's internal to the construction team, if they're running into an issue, they want to confirm measurement widths of piles to make sure that we can drive vehicles through them, or communicating them to the end customers. What's the progress of the customer's site? How are things looking? Being able to perform that level of communication as well. And taking it a step further, the VR environment allows us to support operator training, putting them into a virtual machine and learn how to operate a bulldozer, a shovel, or a dump truck. And then one day, possibly even the full remote operation of the machines through the VR environment. Going even further and kind of stretching it out into the GeoGeek world and larger is bringing smart construction into the metaverse. So we're looking at ways with Cesium for Unreal now to incorporate this frequently captured high resolution data that we see, add that to advanced 3D models that are out there, whether it's vehicle models, the terrain, different objects on the site, and then support that information from real-time intelligent control machines and active geospatial content that's provided and fed into the display. Provides an immersive digital representation of a construction site. Can support site planning, operations. Again, it's the same thing with the VR where we can reduce the site visits and improve overall safety. So the data is out there and it's available. There's no shortage of questions we want to ask. Bringing the data and the questions together is the heart of digital transformation, and where Cesium is playing a leading role. And working with our partners at Komatsu and Hunsinger, we're going to be able to showcase how we're effectively bringing that data together to support the construction industry. So with that, I just want to thank you for your time today. They'll be able to talk a little bit about the digital transformation and the data sources that we're bringing together. And with that, I'm going to turn that back over to you, Muthu, and then the rest of the folks to dive into the details on smart construction and how SC Dashboard is helping day-to-day activities. Thank you.